starting off writing my reaction, calcium carbonate with sulfuric acid. Calcium carbonate is that. Sulfuric acid is this. Ideally, you know that this is not a double displacement reaction, even though we have two compounds reacting. That's an acid, that's a carbonate, and those words are showing up in the question as well. Acid carbonate is a different type of reaction. It shows up on your reaction cheat sheet, telling you that you make CO2, H2O, and the leftovers, meaning the part of the acid that isn't hydrogen, sulfate in this case, and the part of the carbonate that isn't carbonate, calcium. +2 with a -2 is how we get calcium sulfate. Checking this, it is already balanced, but you do want to balance them generally. So there's our reaction. The next thing, limiting reactant or not. Since I have grams of this, I can find moles. And molarity and volume of that, I can find moles. Two things to find moles of. That means I'm going to use an ice chart. So for the 2.12 grams, I'm going to go ahead and find moles. Calcium carbonate, 40 plus 12 plus 16 times 3. Molecular weight is 100. Oops. Our moles are 0.012, 0212, sorry. Should have been able to do that in my head. That is our moles of calcium carbonate initially, so they go in the first row of my chart. For sulfuric acid, that information, molarity equals moles over liters. I had to turn the 40 into liters by moving the decimal 3 times. So we get our moles to be 0.048. That goes here. That's in the I row, but we need C and E as well. Our products, we don't have any to start, so they all start as 0. We're also always increasing our products, so this side is plus. Coefficients are all 1, so these just have 1x. This side is minus, coefficients are also 1, so also just minus x. To find out which is limiting, I would take both of these moles and divide them by their coefficients. Now, normally I do that on the side of my paper. Since both of these have a coefficient of 1, really I can just compare two numbers in this case. Deciding which is smaller, this one, tells me that that is our limiting reactant, and therefore that's the one that runs out. I use that column to help me find out what x is. 0.0212 minus x is 0, so x is 0.0212. That x value now gets plugged in here, 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 and here, and I combine these to get my end. So 0.048 minus 0.0212 is how I get the moles here. 0 plus 0.0212 is 0.0212. Same for all of these. This whole chart is in moles. Now, depending on what it's asking you for the answer, generally we're going to be getting to grams for our next step. So it wants the mass of water produced. That means I just need to take my moles of water. Grams equals moles times molecular weight. 0.38. Now, if you hadn't recognized that this was a limiting reactant problem, you have a 50% chance of getting it right. If you happen to use the 2.12, you would have, ultimately using Stoich, still gotten this answer. But if you had used the 40 mils of 1.2 molar, because that wasn't our limiting reactant, we get the wrong answer. So make sure, even if you're getting these right, you're using the correct process.